Today I'm going to be teaching methods for solving integrals, specifically ones that use trig substitution for Calc 2. So to start, I think it's important to understand this equation, the cosine squared plus sine squared equals 1, because it's going to allow us to decide which trig substitution we want to implement once we actually get to the integrals. So from this equation, we can find our secant and tangent equation. So if we divide the whole thing by cosine squared of theta, it's going to allow us to get a new equation. So cosine squared over cosine squared is 1, plus sine squared over cosine squared is tangent squared. And then 1 over cosine squared is secant squared theta. So now we have a way to get our tangent and secant. So we have secant equals 1 plus tangent. And then if we wanted to, we can manipulate it, get tangent equals secant minus 1, which is, only memorizing this top equation, the cosine squared plus sine squared, that's easy to memorize, equals 1. It's an easy one to memorize. I have a hard time memorizing what secant squared equals and what tangent squared equals, and this is how I figure it out every time. It takes like 2 seconds. So now that we have that, we can get into an actual problem. So now we're going to do the problem, the integral of x cubed times the square root of 16x squared minus 9 dx. And the way we're going to actually figure this out is by substituting something in for x that will turn our that's going to turn our 16 into a 9. First off, we want the 16 to turn into a 9, and then we want there to be some trig substitution we can make from up here to be able to then take the square root of that. So first, we have to think of what do we want x to equal. Since this is some power of x minus a constant, I want some trig substitution minus a constant up here. So let's see. Sine is equal to 1 minus cosine. So that's not a trig minus a constant. That's a constant minus a trig. Up, and then if we go down to the tangent, 1 plus tangent, that's not what we want. But what we do want is tangent squared theta equals secant squared theta minus 1. That works because we have our trig minus a constant. So we know we want to use secant. We want x to equal secant theta. Now we need some sort of constant in front of the secant to turn the 16 into a 9. So that way we can take the 9 out. And it looks like we're going to have the x be squared, so we want to multiply by something that is going to when squared will turn the 16 into a 9. So if we divide by 16, it'll get us 1, and if we multiply by 9, it'll then turn it into a 9. So we want when squared, it's going to equal 9 over 16, because 9 over 16 times 16 will get us 9. So what is the square root of 9? Square root of 9 is 3, and the square root of 16 is 4. So we want 3/4 secant theta to be x. And now we're going to take the derivative of that value we just found. So we want to take dx, take the derivative of x, and then we take the derivative of 3/4 secant, which is 3/4 secant theta tangent theta. So now we're just going to plug in to our original equation. We're going to plug in our x value and our dx. So our x here is 3/4 secant theta, and that x is cubed, times the square root of 16 times 3/4 secant theta and that's squared minus 9. And then we're going to plug in our dx, which is times, and there should be a d theta there, I forgot that, times 3/4 secant theta tangent theta d theta. Okay. So now this, we don't have to actually solve it. The question just wanted us to insert that, figure out what the x would equal into the equation. But if we wanted to just figure out what this, how it would become easier in this this radical, we can see that the 3/4 squared would be 9/16 times 16, and then times secant squared theta minus 9 still. So now we see the 16s are going to cancel. We can pull a 9 out of this, so we would have radical 9 times secant squared theta minus 1. And if we go back up here, what's secant squared theta minus 1? Secant squared theta minus 1 is equal to tangent squared. So now we have radical 9 tangent squared, which is a lot easier to take the square root of, because square root of 9 is 3. Square root of tangent squared is tangent. So we just are left with 3 tangent. And then obviously, if we were actually solving the problem, we would look at the other terms. We would look at the 3/4 secant theta cubed and the whole dx term that we substituted in. But we're going to look at a different problem for right now. All right, so this time we're going to have the integral of 1 over x squared plus 9, and that's quantity cubed dx. So now we're going to try to find that, and this is going to be another trig substitution. As you can see, we have some quantity of x with being added or subtracted to a constant. So we're going to have to do another substitution. Oh, and this is 3/2, not 3. So now what we're going to do is, we see that this is x squared plus 9. We're going to want to do the same thing where we want, when this term is squared, the coefficient is going to, when squared, want to be equal to 9. So it's just the square root of 9, which is 3. So we're going to want to plug in an x. So we know we want a 3, because then we will be able to pull a 9 out, like we did in the last one. And we know we want it to be added. So if we consult up here, let's see, 1 plus tangent squared equals secant squared, that's being added. The other ones are subtracting the constant. So we're gonna be adding, so we want to insert tangent. So x equals 3 tangent theta, and then dx is equal to 3 tangent, the derivative of tangent is secant squared theta d theta, or d theta. So now we are going to insert our x and our dx, and we're going to solve this one fully. So we have the integral of 1 over 3 tangent theta squared plus 9, and then that's to the 3/2, and then we're going to insert our d x in. So then we're going to have on top, we're going to have 3 secant squared theta, and then this is all in terms of theta, so d theta. All right, and then now we are going to square the 3 tangent theta term. So we have 3 secant theta squared theta over 9 tangent squared theta plus 9 to the 3/2. All right, d theta. So that was just squaring that term. Now we see we have a 9 we can pull out. So we have 9 times tangent squared theta plus 1. And this is all to the power of 3/2 still. And we have a 3 secant squared on top still. And then our d theta over here. So now I'm noticing we can take the 9 out. 9 to the power of 3/2 is just the square root of 9 to the power of 3. So the square root of 9 is 3. To the power of 3 would be 27. And we can take this 3 is also a coefficient. We can take those both out of the integral and have 3 over 27, or 3 over 27, which is just equal to 1/9. And then inside the integral, tangent squared theta plus 1, that is equal to tangent squared theta plus 1, as we were setting up earlier. We know that one is equal to secant squared theta. So we can just replace that with secant squared theta. So 3 secant squared theta over secant squared theta to the power of 3/2. All right, d theta. So we're almost done. Now all we have to do, we're gonna cancel. We're gonna make this 1/9. We're gonna cancel. We're gonna take secant squared theta to the power of 3/2, which is secant cubed. So we have secant cubed theta, and there should not be a 3 there. I already took that out. Secant squared theta. So those are going to cancel. We're going to be left with 1/9 1 over secant theta d theta. Now, if you get to a point where you have secants and you have tangents and you don't know what to do next in an integral, you can always turn them into cosine and sine. It helps to like kind of clear things up, and you know the integral of sine and cosine pretty well. So what you want to do here is you want to recognize that secant theta is equal to 1 over cosine theta. And then since secant theta is 1 over cosine theta, we can flip this. 1 over secant theta is equal to cosine theta. So that's just cosine theta there. And we have the integral of cosine theta 1/9 d theta. So now all we have to do is find what's the integral of cosine theta. It's just sine. So we have 1/9 sine theta. All right. So that is almost the correct answer. The only thing is we need to substitute it back in terms of x. So how do we do that? We said x is equal to 3 tangent theta. So 3 tangent theta is equal to x. So tangent theta is equal to x over 3. All right, so you're going to use this term, when you substitute x, you're going to use the isolated trig, and you're going to make a triangle with it. So if this one is theta right here, then tangent of theta is x over 3. That's opposite. So x is opposite over adjacent. So 3 is adjacent. And then the hypotenuse would just be Pythagorean theorem. It would just be square root of 9 plus x squared. So now we can find what sine theta is. There should be a plus c here. But we can find what sine theta is by doing the opposite over hypotenuse, because that's what sine is. So it would be 1/9 times sine theta is going to be x over square root of 9 plus x squared plus c. So our final answer is x over 9 radical 9 plus x squared plus c. So, thanks for watching. I hope that helped a little bit. See ya.